Okay, we'll just check we've got everything set up here. Just make sure everything's coming through on the live stream. Just give me one moment. Okay, all right. Okay, sorry, a bit late today. Just had some family things to deal with before I could get stuck into this. All right, so let's begin with the complex numbers question for today. All right, so we have this set up with W is 2 minus 3i, and that's a solution to this equation here. We've got a missing piece of information with the a there. We're going to have to work that out at some point, and we're going to find the value of a and the other two solutions. All right, so the very first thing to do, if w equals 2 minus 3i is the solution, then let's say that's the first solution. Then the second solution is 2 plus 3i. Okay. Oh, that's a 3, not a 2. There we go. So the complex conjugate is always a root as well. So if you've been given a complex root, then straight away write down the conjugate as another root. Usually that is straight away an achieve point, just for that, knowing that little bit of information. All right, now next up. Sorry, I'm just trying to get my things in order here. All right, so we are on to needing to work out the a in this equation. So if we have 2 minus 3i as a factor, is a root, then we can make a factor of the expression by doing w minus the root. So w minus 2 minus 3i, that's a factor. W minus 2 plus 3i is also a factor. So if we times that together, we will get another factor. What we will also have is a third factor, and this third factor, we need to fill in the missing pieces of what would go in there, and that will help us to work out the a that we're looking for. Okay, so that's what we're aiming for. Before I go on with that, I'm going to multiply out this bracket that we've got here of the first two factors that we've been using. Okay, so if I multiply out this bracket, I will have w squared minus, I'm going to keep this portion of it still in that bracket form. So that'll be minus 2 minus 3iw, and then so I've done this one times this one, I've done this one times this one. Then I will do this one times this one, so minus 2 plus 3iw, and that just leaves us with the last one, which is that times that. So that'll be a plus 2 minus 3i, 2 plus 3i. Okay, so in fact, I'm going to just do a little bit of color coding here. So let's put that in pink. That's the piece that I'm working with just now. Now I'm going to use the calculator to help us, because we don't need to do any unnecessary work when the calculator can do a fair bit for us. So we got 2 minus 3i multiplied by 2 plus 3i. So that comes to 13. So this portion just here. Oh, actually, at this point here, I'm now going to multiply out by the w. So this is minus 2w plus 3iw. Minus 2w minus 3iw plus the 13 that we just got from the calculator for those two bits being multiplied together at the end. Now you can see that we have some things that cancel out. Oh, I've got an extra I in there that shouldn't be there. Just one moment. There we go. So this 3iw cancels with this one because we've got a plus and a minus. And it leaves us with w squared minus 4w plus 13. Okay. And I'm just checking what mark that would have got you to at this point. So if you get to that without the, finding the second solution, each of these kind of stages along the way on their own would be getting an achieved point, depending on what order you do things in. Right, now, back to what we were doing with getting this bit of the bracket here. So if I now take this w squared minus 4w plus 13 in place of what we had here, that's going to be multiplied by another bracket to make the polynomial that we had to begin with, like this. Okay. So now what we're going to do is put those things together to work out what's in the gap there. So what would I multiply this quadratic here by to make the cubic that we have over on this side? So if we're smart about it, we can just pick out the key pieces that would help us with that. Now, the first thing to think about is what would go with the w at the front of that factor bracket. So with the 3w cubed here and a w squared here, what we would need to make 3w cubed is 3w, so that when these two times together, it makes this one here. Here we go. So let me see if I can just tidy that up again. And then we will have a number in this section here. Now the number we will get by doing 13 times something will make minus 26, because we can only get the constant at the end by multiplying the constants within the factor brackets. So obviously that has to be minus 2. Okay, so we've got 3w minus 2 is the third factor, which helps us to find the third root. So the third root now is 2/3. Okay, so we've got our three roots here, here, and here. The last thing is to work out the value of a. Now we can get w pieces, so just compare the terms that have w by taking what's on the left and what's on the right to make w's. So on the left we can make w by doing minus 4 times this constant here. So let's go with that blue. Okay, so we got a minus 4 times minus 2, so that'll be a plus 8w. We can also make w term by doing 13 times 3w. So that would get us a, what's that, 39? Just had a moment there, 39w on the left. On the right, the only term that we have that's in single w's is this one here, the aw. Okay, so let's just highlight that. So we're just looking at w terms. Over here we would have aw. So therefore a has got to be 39 plus 8. Okay, now all of those pieces together get you the merit. There are some places, let me just tidy this up a little bit so I can get rid of some of those distractions. I don't know if I'm going to do this well. And then I'll show you all the possible places that you could get achieved out of this. So you can have an achieved if you get the, what should we highlight this with? Let's highlight it green. If you get a equals 47, that's worth an achieved. If you get the one of the roots being 2/3 on its own, that's worth an achieved. If you got this quadratic, that was also worth an achieved. And if you wrote down the conjugate as a root, that was achieved. Now, you don't get multiple achieved within this question, but there are multiple places where you could achieve the one, where you could get the one achieved mark. All right, on to differentiation. This is one of my favorite kinds of questions. I really enjoy the graphing ones of this. I think it's easy to see the things that you're being asked to do. So we'll have a go at this one now. We've got a graph that shows a function y equals f of x. And with that, we've been given some information, and we are asked to read off the graph and figure out the answers to these questions. So we want to find the values of x, or that means the points on the graph, and label them by their x values, where f of x is going to fit these situations down here. So the first is that f of x is not differentiable. Now, not differentiable happens when you have a break in the graph or a sudden kink in it. You need smooth curves or straight lines to be able to do differentiation, to be able to find a gradient of it, and that doesn't work if you have any sharp corners or any holes in the function. So when you're doing these, read them from left to right, and then look for the places where you would have gaps and kinks. So if we take a look at this graph, the first one as we come across from the left is where we have this asymptote of -2. That gives us a gap. So it's not differentiable there. The next gap is here at -1. The next is here at x equals 2. And after 2, it carries on forever to the right. That's what this arrow is telling us. Okay, the second point, the second derivative is less than 0. That means we've differentiated twice. We're at the point where it can tell us about the nature of roots. And if the second derivative is less than 0, it means we're on a maximum. So we're looking for any values that belong to a maximum. And that is this portion just here. So this curve that I'm just sort of highlighting there, all of that is part of a maximum. So we're not working out where the maximum point is, but any piece of the graph that belongs to a maximum, or that upside down bowl shape. So this is that we're going to have everything that is to the left of -2. So x is less than -2. And all of the values to the left of -2 belong to that parabola that's upside down. Okay, the third one, any part of the function where its value is not defined. So f of x is not able to be found. And the only place where that happens is right here on the asymptote line. If you put in the value of x equals -2, you wouldn't be able to find a place on the graph, so you wouldn't be able to give a value for it. So we've got x equals -2 on this one. Part 2, what is the value of f of 2? So looking at x equals 2, we're looking for the portion of the graph. The only confusion might be between these two here. Do I take this one or that one? Well, we always take the coloured in ones. An open circle means the value is not there. We have to look for the coloured in one. So at f is 2, our value is 4. All right, last one, what's the limit as x goes towards 1? So if we're approaching 1 from both sides, we're not looking at what happens exactly at 1, we're looking at what happens as we come towards it. So from the left-hand side, we're heading this way. From the right-hand side, also heading that way. So we're heading towards the same point, and it's finite. So what that means is we have got a limit that is just here at 3. So we're heading towards there, the y value at that point is 3. Okay. I'll just go and check where the achieved was for that, if I've got that open. Okay. All right, so there's 5 possible answers on that. If you got 2 of them correct, then you got the achieved, and if you got 4 of them correct, then you got a merit. So of these 5 places to give an answer, 4 for merit, 2 for achieved. Right, let's see if we can get to the integration. Here we go. Right, here's our integration one. We've got a function of sine is x over 2. The lines x equals k and x equals pi are marked on here. We want to find the value of k so that the areas A and B are equal. So k has to be placed somewhere that it splits up that area into 2 equal pieces, which means that we are going to integrate those 2 halves to find the area underneath, set it equal to each other. Right, so I'm going to just squish this up so we can fit enough space for working out. We're going to integrate the function sine is x over 2. In fact, I'm going to write that as half x. I find that easier to deal with. Now, if we do that between 0 and k, that will give us the area of A. That will be equal to the area of B, which is if we did it from k to pi for that same function. Okay, now integrating sine, I'm just going to double check the formula sheet. So I've got lots of windows open. Let me just find the right one. Okay, because I can never remember whether it goes to positive or negative. Always have to check the formula sheet. So sine integrated goes to negative cos. So this would be negative cos of a half x divided by the half, because we're doing reverse chain rule. So if we divide by half, we'll times by 2. So that is minus 2 cos half x between 0 and k is equal to the same thing if we do it between k and pi. Okay. Oh, sorry, I'm just losing my windows for a second. Here we go. All right, so now we'll substitute in the values and work through to figure out what k needs to be. So if I pop k into this first one, we have cos of k by 2. We're going to minus from it if we substitute in the minus 2 cos half of 0 is 0. And that is equal to, on the other side, we've got minus 2 cos of pi by 2, take away minus 2 cos of k by 2. Okay, let's tidy this up. So we've got minus 2 cos k by 2 plus 2 cos 0. Well, cos of 0, let's just double check. Cos 0 is 1. So then we're going to have a plus 2 times 1, so that's a plus 2. Cos of pi by 2, like this, that's a 0. So we have 0 plus 2 cos k by 2. Right, now we've got 4 cos k by 2 by bringing this cos over to add it together. That will be equal to 2. So cos k by 2 is equal to 2 over 4, which is equal to a half. Now go to your special triangles on your formula sheet, because cos being equal to a half is one of those special triangles. And I'm just going to check I haven't made any silly mistakes. Yeah, I'm doing okay so far. All right, so special triangles I'm talking about are the ones where we have 1, 2, and root 3. And if cos is equal to a half, well, cos is the adjacent over the hypotenuse. So the adjacent being 1, the hypotenuse being 2, would give us cos being a half. So we're looking at this angle here that is adjacent to the 1. So that's 60 degrees, or pi by 3. So cos of pi by 3 is equal to a half. So therefore, if cos k over 2 equals a half and cos pi by 3 equals a half, then k by 2 has got to equal pi by 3. So k is equal to 2 pi by 3. Okay, and I'm just looking up where the achieved was. Okay, if we get to, let me just find it in my working. It was when we subbed in. So this line here, oh, that's not a good colour. So this bit just here, getting down to that third line down where we've substituted in and started to work out what that would be, that was the achieved point. Okay, that's us for this evening. So another one where we've managed to do 3 merit questions. Those ones felt like they were perhaps a little bit longer than the other ones, or maybe it's just that I was taking a bit longer than usual, not quite onto it at this time of the night. We'll do another one tomorrow. What I was thinking is that I'll see if I can grab the questions that we'll do tomorrow, and then anybody that wants to have a go at them first can sort of get a bit of a head start. So if you want to stick around and see the questions I'm going to plan to use tomorrow, then you can. Otherwise, I will just see you then. Plan is to be online at 8:30 tomorrow night. Okay, so in the meantime, I'm going to grab the questions that I've been planning to do. All right, I've got one for complex numbers. Just need to check it actually is a merit question because it's a little bit of a weird setup. Okay. Okay, and then there's another part to it as well. Okay, so this will be our complex numbers question for tomorrow. Let's get a differentiation one. Okay, this is the differentiation. Okay, and then an integration one. Let's grab that. Oh, I like the look of this one. Okay, so here's the integration one. And I'll see you tomorrow to have a go at those.